Today is our new unit, that is name is sound, right? What is the basic fundamental behind of the sound and that characteristic? Let us talk about the sound. So which are the content we have to study into this unit, that name is the sound. Let's talk about the mechanism and propagations of the waves. Obviously, the sounds behind of the physics, we have to first in our mind, in our nerves, first which is the waves. Okay, types of the waves and the wave motion. Motion means ki how to be transmitted factor. This is called as the motion. Important terms connected with the motions, because in the motionated form waves always transmitted. So what is the terms or the terminology which is connected with the motion of the sound? Characteristics of the sound. What are the characteristics of the sound? Vocalization and hearing and application of the sound in the nursing purpose. Okay, these all are the content we have to study in this unit of the sound. Next one, mechanism of propagations of the waves. What are the propagations of the waves? Like, this is the very first content we have to start about the sound. So let us focus on the basic terminology of the sound. Propagations means ki connected and that phases. First one, kinetic energy. What is called as the kinetic? You know about the energy, but what is called as the kinetic energy? The energy which is associated with the motion. See, here we are only talking about the sound and the physical factors, means ki physics behind of the biophysics. So, though we are only talking about the related of the waves and that sounds. So, the energy associated means ki connected, appeared, mediated with the motions. Right, this is called as the kinetic energy. The potential energy. What is called as the potential energy? Potential means ki carrying, the capacity of the energy which are carrying very higher. This is called as the potential energy. It is stored energy and depends on an object portions, means ki position. What is called as potential energy? The stored the energy and depends on the object position. What is the object positions? Whatever we are talking about the positions and the object that stored in the formation of the energy which depends on the object stored energy. Next one, inertia. What is called as the inertia? It is the property by which particles can store energy. In a small molecule, small particles which are going to stored in an energetic factor. This is called as the inertia. We have to study it in the next slide. Let us talk about next one, elasticity. Right. What is called as the elasticity? It is the property by which particles can be returned to their mean position after having been disturbed, means disputed. Elasticity, whatever we are stretching, which will be convert in a original form or original form, this is called as the elasticity. Okay, I hope you are understand about the basic terminology behind of the propagation of the waves. Next one. Now the wave. What is called as the wave? The propagations of disturbances from place to place. See here, the place to place in a regular and organized way. This is called as the wave. Means the propagations of disturbances from the one place to the another place by the in a regular and in a organized way, in a evenly. See here, I am taking some animated peak. Observe here. See, this is the one stone which is I put into the still water and the waves are starting uniformly. This is called as the wave. Next one, the wave motion. What is called as the wave motion? It means of transferring energy and momentum from one point to the another without any actual transportations of matter between these points. Means what is called as the wave motion? Motion, a transfer factor, one way to the another way, which is means transferring energy and moments from one point to the another point without any actual transportation. This is not actual transport, this is the waves. This is not actual. There is not responsible actual factor, and the transportation of matter between this point means the transportation factor which between of them. These objects which is going to be transferred by in a motion factor. This is called as the energy. Here we are talking about the energy which is in the formation of the motion. Right. Next one. Let's talk about one another example. Suppose a stone which is dropped in the still water of the pond. We can observe the repulse traveling on the surface of the water in concentric circle of the increasing radius. What is called as radius? A circle factor. Still water, we have to put it down some stone in it, and uniformly the waves and the motions, the ripples which are observed over there. If we put a bottle or some small pieces of the wood on the surface of it water, we see that it moves up and down as wave passes but does not travel with the wave. It is not travel with the waves because the density of the object is very less. The waves or the motions or any other type of the waves which are produced by the density of the objects. Okay, keep it in your mind. This is the basic principle of the physics. Next one, the particles of the medium oscillate about their mean positions, but there is no displacement away from their original position. Means the particles of the medium, whatever medium, here the water is the medium and the particles is object. The about their portions or the position, there is no displacement away from their original position. It is not going to come up back as according to the elasticity. It is going to be expanded according to the object's energy. Right? The throw of the energy here, as we are talking about from to this object's energetic factor. The wave in the water carry energy, but there is no transfer of the matter. Means wave in the water which carry the energy in the formation of the motions, but there is no transfer of the matter. The matter means the transfer of the object which is not matter, but the transfer of the behind of the reason, the motions, the waves which are depends. Right. Next one. See here the stone which is put it down into the still water. The waves are appearing and expanding, the waves motion, and this object which is not going to be swim over there. Next one, the mechanism of the wave propagations on the surface which is based on the properties of the elasticity and inertia of the medium which is water. Here, let's talk about the mechanism of the wave propagations propagate on the surface. This is the surface based on the properties of the elasticity and the inertia, where the medium, the water, the energy which is going to be absorbed in this factor, this is called as the water, which is one type of the medium, and the object which is the stone, yeah, whatever we are put it down in it. Right. So here this is the water factor which is absorbed some energy and convert into the motion-added factors. Right. Next one. As the molecules move downwards with the stone, the restoring force start acting on it due to the property of elasticity of the medium. Means the molecules move towards means as according to the force of the energy with a stone. Why? Because we are taking here as object as the stone. So the restoring force, the force which is restoring, start acting on it due to the property of elasticity of the medium. Whatever stretch which is elasticity means how it will be expand, how will elastic factor is according to the stone's energy, right, the object's energy. As it moves against the restoring force, its speed goes on decreasing and it comes to rest on reaching point A. This is called as the elasticity. We are stretched by something and come back at the one at point. This is called as the elasticity. At this position, energy imparted to the molecule is in the form of its potential energy. The position energy imparted to the molecules is in the form of its potential energy. At a point A, the restoring force is maximum on the molecule and hence it starts returning to its mean position. Means point A to the restoring force which is maximum, which is depends on to the molecule, and hence which is started return to the mean position, means ki which is transferred at it on a mean position. This is called as the elasticity factors. During of this movement, its potential energy gets converted into the kinetic energy. During of this process, which is converted into the kinetic energy, energetic factor which is in a energetic factor which is into the kinetic factor, mechanical factor. This is called as the kinetic energy. On reaching the mean position O, the molecule overshoots its due to its property of inertia and moves up to the point B till the velocity attained by it at the point O or the 0 become the 0. Right. During this movement, all this potential factor and it get converted into the kinetic energy, and which is reaching mean position from to the 0, molecules overshoot which is due to its property of inertia. Inertia means absorptions of the energy into one molecules or the media, which is due to in its property, and point B till the velocity which is attained by it at the point 0 become 0. Okay. In this manner, the molecule of the water executes periodic motions, means which is going to be in periodic factor, one by one. A waves ring by the ring, because it transfer energy by a waves factor about its mean position due to the property of the elasticity and the inertia. The disturbance is communicated to the neighboring molecules of the water, which also being to execute periodic motion about their mean position. What is that? It is disputed, means it is a disturbance which is developed. Why? Because in a still water we are putting down a stone in it, object in it. So the disturbances factor which are create, but which is create one layer to another layer, means ki one water molecules convert energy to the another one layer energy. This is in a forms of the ring by ring, means ki generated waves by waves, which is transfer energy one water molecule energy molecules to the another water molecules, which is called as the waves factor. Okay, next one. Let's talk about the types of the waves. How many types of the waves are there? The elastic waves or mechanical wave. There are, first one, elastic waves or mechanical waves. The waves which can be produced or propagated only in a material medium, means the waves which can be produced or propagated only in a materialistic medium. This is called as the elastic, because the elasticity factor which is always depends on to the objects of that factor only in a material medium. Next one, electromagnetic waves or non-mechanical waves. Second one, electromagnetic wave, or the second one, non-mechanical waves. The waves which can pass even through to the vacuum. Example, light waves from the sun, radio waves, X-ray, etc. What are the electromagnetic factor? Which is the source factor. One of the source, that energy which is transferred by the another factor. This is called as the electromagnetic factor. The electromagnetic waves are non-mechanical waves. The waves which can pass even through to the vacuum. Vacuum factor means absorption. Vacuum absorbed. Example, light waves which are formed by the sun, radio waves, X-ray, etc. Right, next one. Types of the wave motion. The types of the wave motions which is in the two types. First one, transverse wave motion and longitudinal wave motion, which is transverse wave motion, and second one longitudinal wave motion. Let's talk about in detail about transverse waves and longitudinal waves. First one, transverse wave motion. In a transverse wave, the particles are displaced perpendicular to the directions the wave travel, means ki the direction of the waves which are traveled by the way of the transverse waves, means ki one media to another medium. This is called as the C and this is called as the T, right? This is the direction of the waves and this is the transverse wave. Okay, next one, always which is in a date by this factor. The peak point of the higher, which is the C, and the peak point of the lower, this is called as the T, means ki direction of the propagation wave, and this is the transverse wave. A transverse wave travels through a medium in the form of the crest and the throats. See, this is called as the crest, this is called as the throats. It is always in a transfer by the crest and the throats factors. The crest is the portion of the medium which is raised temporarily above the normal position of rest of the particles of the medium when a transverse waves pass through it, means ki crest which is portion of the medium, this is the portion of the medium, this is the portion of the medium, and which is raised temporarily above the normal positions, which is temporarily raised above the normal position of the rest of the particles of the medium when a transverse wave passes through it. A throat is the portions of the medium which is depressed temporarily below the normal positions of the rest of the particles of the medium when a transverse wave passes through it. A throat means ki a T factor, the portion of the media which is going to be which depressed temporarily. Why? Because the throat which is called as depressed the portion of the waves and temporarily below the normal positions of the rest of the particles which is into the medium, absorbed and transferred, absorbed and transferred. This is in a directed factor of the waves. Next one, here I am taking about some peaks of these conditions, directions of the wave, and this is the transverse wave. Okay, this is the direction of the particles vibrations. The particles which is transferred in a two factor in a vibratory mode. Vibratory, this is vibrations mode transfer, energetic factor which is transfer in a crest and in a throats factor. Next one. Second, longitudinal wave motion. So in a longitudinal waves, the particles are displaced parallel to the direction of the waves, which is the transfer of the waves in a direction of the wave. The longitudinal waves travels in the form of compressions and the refractions. Means a longitudinal waves travel in the form of the compressions and the refractions. This is the refraction, this is the compression, this is the longitudinal wave, one wave factor. The two factor name, the diameter and it is similar. The wavelength, this is the compression again, this is the compression, this is refraction, compression, refraction, elasticity, relasticity, right? So this is the portion of called as the longitudinal wave. Next one, compressions. What is called as the compressions? It is a region of the medium in which particles are compressed. Example, particles come closer, means ki which is the region of the media in which of the particles which are compressed, the particles which are going to be compressed. Here the particles are compressed and are close come, means ki which is come to the close. This is called as the compressions. Now refraction, it is the region of the medium in which particles are rarefied. Distance between the particles are increasing. Here the distance of the particles which are very higher increase. This is called as the refraction. A mechanical wave shall be transverse or longitudinal depending on first one, nature of the medium, and the second one mode of the excitations of the vibration. This is the nature of the medium and this is the mode of the excitations of the vibrations. Right, this is the energetic factor which are increased by the one molecules to the factor another. Next one. Another one, that name is the sound waves. What is called as the sound waves? So hearing is one of the primary sensation. Obviously, this is our sensations. There are 5 type of the sensations factor is there, including one of the 6th. This is exceptional, means ki this is the 6th factor. Means ki major is the 5. Out of them, one is the hearing. This is our primary sensation. The physical causes that produces the sensations of hearing is the vibration of the source. Means ki the physical causes which is produced the sensations of the hearing is the vibrations of the source. Right? Next one. Human ear is sensitive to vibrations whose frequency lies between 20 Hz and 20,000 Hz. This is the Hertz which is unit to identify to a Hertz capacity of the human being, normal human being hearing capacity which is identified in this Hertz and which is 20 Hz. This frequency is called as the audible range. Obviously, this is called as the audible range. A vibration whose frequency is greater than 20,000 which is called as the ultrasonic vibration. Means ki vibration of this frequency which is going to be increased or the greater if you are identified, which is called as the ultrasonic. The sound waves which have frequency less than a audible range are called infrasonic waves. Means this sound wave with frequency which is less than a audible range are called infrasonic waves. This cannot be heard by human ear. This is not heard by this normal human being, human ear. Now let's talk about the hertz. What is this is the symbol of the hertz. Hertz is a unit of frequency which is defined as the number of complete cycle of periodic signal that take place in a 1 second. It is 1 second how much amount of the sounds which are going to be observed and which are hearing this cycle which is called observed by the hertz. How to be heard unit which is applicable for hearing factor. Okay. See, this is the frequency, this is the distance and this is the time. This is the hertz is equal to how much cycles of the sounds which are depict onto the 1 second. These are the cycle and these are the seconds. This is the time. Now, ultrasound and infrasound. Second waves with a frequency too low for the human ear to hear are called infrasound, means infrasound. Sound waves with a frequency too high for the human ear are called ultrasound, means ki with the frequency too high. These frequencies which are going to be very higher for the human ear are called as the ultrasound. See, this is the below 20 Hz. This is 20 Hz to 20,000 Hz. And over this is ultrasonic factor over the 20,000 Hz who are identified by the human being, not human being, sorry. Such 20 Hz below, many animals like animals such as the whales, elephants and hippopotamus use infrasound to communicate over the distances. Here we are human being. This is the range of the hearing factor. Higher to the 20 Hz to 20,000 Hz, which is the animals such as dog, bats, birds, insects can hear the ultrasound. That the ultrasound's range is very higher than the 20,000 Hz. The velocity of the sound in air at the room temperature and normal pressure is 332 minute per second, which is 1200 km per hour. Velocity sound, see here 1 and second person, This is the waves which are appear by these motions, and normal pressure which is the 332 minute per the second, about 1200 kilometer per hour. The sound travel in the form of the longitudinal wave. See here, the travel by the longitudinal. This is the longitudinal wave. This is the longitudinal wave. The distance are compression and refractions. Here, this is the longitudinal wave. Right. Next one. Sound is measured in a decibel. Sound always measured by some decibel. Like here, to irreversible damage, danger, harmful sound, harmless, threshold, and no risk. This is the, here we are getting some color to differentiate about the sounds and their effect on human beings. Let's talk about the first one, this color. This range is the 120 to 140. 120 to 140. This is irreversible damage. This is the range between a yellow color, which is danger, harmful sound, which is always observed by these waves. This is the plane takeoff, which is observed in irreversible damage. This is the pneumatic drill. See, this is the drilling factor, which is always harmful, danger sound. The sounds which range is very less, which is 80 to 90, observed by the playground. The normal voice, which is 40 to between up to the 40 to 60, like normal voice, like speaking, smiling, chit-chatting, this is normal. Okay. This is the very whispering, very slow between. This is the green, no risk. Means ki this is the slow down, very slow down. It's haven't any risk. Means ki whispering, right? So this is the differentiate between of the measured in this decibels. Next one. Important terms which is connected with the wave motion. So like wavelength, it is the distance from one crest to another crest or another, or to from one throw to another of the wave. What is called as the wave? The distance. See, this is the factor. Obviously, this is called as the crest. This is called as the throats. Okay. So, one crest to the one throats to travel one direction to the another direction. This is the distance. How much distance between crest and the throats? How much wavelength which are observed, which is called as the wavelength. Always which is depends on to the motions. Next one. Frequency. Frequency is the number of the waves that passes a fixed point in unit time. Means that this is the high frequency, this is the low frequency. Frequency always depends on to the wavelength. How much wavelength which is different between crest and the another crest. This is the difference. If the distance is one crest to the another crest is high, it's called as the frequency is very low. And if the one crest to the another crest distance which is very small, this is called as, or very less, this is called as the high frequency. Okay, this is the distributions of the frequency. Just you have to understand about these things, because we have to observe in a biophysics. We are not studying a pure physics. We are studying about the biophysics. So you have to arise in your mind, why should we have studied a biophysics? Because some of the instruments, some of the medical situations we have to handle in a physics form. So biophysics like a cardiac factor, ECG, you all see in this manner. So what is the distance, travels, absorptions, excretions, which is depends on to the physics law. So in this way, we have to study about the biophysics way. Are you getting my point? Next one. The time of the period. The time taken by the wave to travel a distance equal to one wavelength. Means this is the one wavelength. Time of the period travel to the time taken by the wave to travel a distance equal to one wavelength. This is the time of distance between of this one crest to the another crest. This is the how much time period it appears. Now the velocity. Velocity of a wave varies with the medium through which the waves are passing and the temperature of the medium. What is called as the velocity? The waves which is different with the medium. Obviously, that depends on to the absorption capacity of the conditions, which is depends on to their medium condition, which throw by the waves which are passing and the temperature of the medium. Velocity of the sounds, which is depends on the pressure and density of the medium which is passing by, depends on to the pressure obviously, and density of the medium through which it travel. Sound wave conductions is best in a solid and poor in a gas. Why? The molecules of the conductivity or connectivity which is very small, means ki high frequency and the low frequency, as according to the moleculars, one molecule to the another molecule's distance is very less, so the transverse factor which is very higher, and in a vice versa, in a gaseous factor, the one molecules to the another molecule's distance is very higher, so the transfer of the frequency is very less, means ki very poor. Now let's talk about the intensity. Intensity is the energy which is carried by a wave in a unit time across to the unit area. Like intensity means ki what is the intensity? What is the intensity? Means ki how much potentiality of the voice or the sounds which are appear. Like intensity depends on the amount of the energy which the sound waves strike the tympanic membrane of the ear. This is the tympanic membrane, this is the appear, means ki here start some factor of the voice, means ki this is the speaker and this is the traveler portions by the waves, by the motion. The first nearby persons who identified sound very fast or very easily, the time traveling is very less, connect to this person because it's transferred by one medium to another medium, distance is very higher, the hearing time is very higher, as according to the transfer factor. Amplitude. What is called as the amplitude? The amplitude of the waves which refers to the maximum amount of displacement of a particle on the medium from its rest position. What is called as amplitude? The amplitude factor of the wave refers to the maximum amount of the displacement of the particles on the medium from its rest position. This is the amplitude and this is the wavelength. Okay.